Hello students. So continuing our lectures on electro pneumatics, and we in the last class at the end we said that the electro pneumatic control has got three important steps. The first one is your signal input device. Such as switches, then you have contractors, contactors, then contact and proximity sensors. The second important step is your signal processing. Which also consists of contactors, relays, and PLCs. The third important step is the signal output. Which consists of output used for outputs which are used for solenoids, indicators, or audible alarms. So these are the three important steps in electropneumatic control. And now, apart from these three steps in electropneumatics, there are 7 basic devices, electrical devices, which mainly control the fluid power. So these 7 basic electronic devices are push button switches, Then you have limit switches. The third one being pressure switches. Fourth one is solenoids. Fifth one is relays. This one is timers. The last one being temperature switches. So these are the 7 basic electrical devices for fluid power control in electro pneumatics. Now we will take up one by one. First we will start with the push button switch. These are basically close or open electrical control circuits. So close or open circuits, and they have a manual override. In case of emergency. They also have something called a momentary button. Now, these momentary buttons are returned to their original positions when they are released. So, they are actually a sort of they always when they need to be actuated when in use. When they are not actuated, they return to their original unactuated positions. They are maintained by something called a mechanical latch, and which actually holds them to their selected position. Now the contact of push button, there are basically 3 contacts. First is open, normal, open, call it as NO, then normal closed, call it as NC, and there is a changeover. It has CO. So there's 3 contacts of the push button. The momentary contact type, the schematic representation of the momentary contact type is like this. So this is basically, I'll explain the terms a little bit after a little while. Let me first draw the schematic. So this is basically your momentary contact type push button, and it consists of two normal open and two normal closed. Now these two are the normal open positions, and these two are the normal closed positions. From the diagram you can understand there is no contact between these two positions, so these are normal open. And whenever we are representing, say like this, where we have told this one as 13 and this one as 14, so the first digit it implies, it tells you about the function of contact. Function of contact, and the second digit it tells you about the serial ordering. So 3 and 4 means that there is no contact. As you can also see from the diagram, there are no contacts here between their open positions, and the first one is your serial number. So this is the first serial number, this is the second serial number, so this is second, this is the third serial number, and this is the fourth serial number. So 1, 2 and 3 and 4. So 3 and 4 in the second place indicates that it is in the no contact region, whereas 1 and 1 and 2 and 2 indicates that these are in the contact region. So there is two no open positions and two closed positions. Now this is the momentary contact type push button switch. There is another one called maintained, or the normally mechanically manual override of the push button switch. So we'll call it maintained. We maintain the contact, maintained contact push button type switches. So let me draw the diagram first. Again 13, 14, this is 23, 24, 31, 32, 41 and 42. The only difference this diagram has is with this indication here, which indicates it is mechanically, or it is mechanically latched, rather, sorry, not mechanically latched, it's not momentary, it's maintained contact. Now, the normal position of a switch button looks something like this. Is the schematic representation. Normally, if you look into the devices, so push button switch actually looks something like this. Sorry. This is the spring, and these are the contacts. And this is basically the switching element. So you can see that the spring actually maintains whether it will be in contact or not. This is in the normally open position, and when these there is a joining, these are joined, this switch is joined with this one, so it becomes normally closed position. Okay. And this is the actuated position, this is the normal position, and if we join it, it becomes the actuated position. And the symbol for the actuated position is like this. This is for the open position, and when they join, it becomes like this, closed positions. So this is 3 and 4, and where this is represents 1 and 2. And the changeover position, so actuated, or we can also call it as the normally closed positions, NC. So this becomes NC. Whereas there is a changeover position, which is like this. So changeover. So this is when we are dealing with two different switches. So this is then in this case the first one, so this one is in the normally closed positions or actuated positions, and this one becomes a normal open position. So this is on a whole, this is the normal position of the changeover switch. And when the interchange of this switch occurs, that means the first one becomes closed, whereas the second one becomes open like this. So this is now NO, normally opened, and this is now normally closed. When this changeover occurs, and this is an actuated position, then we call it as a changeover switch, and it is represented in this fashion. So we have so as you can remember, 3 and 4 would indicate open positions. These indicate open positions, and 1 and 2 represent closed positions. So in the first case, since it was an open position, so we represented it by 2 and 1, whereas as the changeover occurred, so it is open position, so 4. So this is the changeover push button switch.